Hello everyone, just a wee short video tutorial today, just covering the last part of this first chapter from the vectors, scalars and acceleration section. So the last wee bit is on acceleration, and on virtual physics here, if we just go into our dynamic universe, still in the introductory section, and we're just doing the last slide here on acceleration. So we're just looking here at the car accelerating, okay, from left to right. And so what we can see from that little simulation, what it allows you to do here is it allows you to set a timer. We're not going to do any of that, we're just going to look at the car in a wee minute, frame by frame. The timer is actually on there. So on the next slide here, it shows you the car frame by frame. So it's moving forwards a fraction of a second each frame, and we can see the position of the car changing. So that is what it would look like if you have an object accelerating. Each frame the car moves a greater distance, okay, which indicates that it's getting faster, obviously. What's also popped up on the screen there is your formula for acceleration. Again, something that we covered at National 5. So A is the acceleration, which remember is measured in meters per second squared, or ms minus 2. V is the final velocity of the car, so at that point here. U would be the initial velocity of the car at the start, which would be in this case at rest, and T is the time that the car takes to travel from A to B. Okay, so you have your reference points. It might be that we start the initial reference point here, in which case the initial velocity would not be 0. So we'll be looking at examples like that when we come to the next section on equations of motion. So it's not the case that the initial velocity is always 0. Sometimes we have a starting velocity and then a final velocity, which both are non-zero. So that's just a quick revision of the formula for acceleration. In your learning, it comes in the tutorial questions that you're going to be working on today. It mentions the experiment to measure the acceleration of the trolley rolling down the slope. So that's where you can have two photo gates, one positioned near the top, one positioned near the bottom. The one at the top is for measuring the initial speed, and the one at the bottom for the final speed. And what they can also do is to record the time interval between the two gates, and that's the time that actually gets used in the formula here. The other two times in the photo gates are used to measure your two speeds, initial and final speeds. Okay. Any questions about that, guys, you can let me know, but most of this stuff you should remember from National 5.